Hi, good evening all. And after this January 1st, this is the first class we are doing, right? So happy New Year to all of you. And I wish this year, the Gate 22, which you are going to write, so you'll be doing very great in exam and your career. Okay. So in the continuation of our series of digital sum of sessions, so today is, January 4th, and this is our fourth session, right? So in today's sessions, I have planned to cover up this combinational circuits. And you know the importance of combinational circuits. Like every year, there is one question from this particular topic, and from the combinational circuit topic. So if there is one question, 99% of the chances it will be any of these four models which I have given. So the first one is based on half adder, half subtractor, full adder, full subtractor, ripple carry adder. So based on the adder circuits, so you may have one question. And the second question is based on the magnitude comparators. Third model question can be based on the multiplexers. Fourth model question can be based on the decoders. Okay, so let me just in brief, let me give you some overview of this adders, and then we'll be coming into the question part. So this is what, again, I'm referring our handbook, which is the digital handbook. So in your screen. So let me give you some of the key points, and then we'll go into the corresponding question session. So one thing that somebody should note is whether it is a half adder or half subtractor, the sum and difference expressions are same. That is A XOR B. For half adder as well as for the half subtractor, the sum and difference expression are same. Carry expression of half adder is AB. Borrow expression of half subtractor is A bar B. So this is very important to memorize this particular, standard informations. It's not like if you don't remember, you cannot answer. But if you remember, sometime it is definitely going to help you. You can save some time. Same is the story for the full adder and full subtractor. Here, I would like to highlight again, in case of full adder and full subtractors, the sum expression and difference expression are same. Their mean terms are 1, 2, 4, 7, with the assumption A is MSB and C is LSB. So the mean terms are 1, 2, 4, 7. And if you try to get what is the corresponding expressions for this 1, 2, 4, 7, it is A XOR B XOR C, or it is equivalent to A XOR B XOR C. Similarly, the carry mean terms are 3, 5, 6, 7, and the borrow mean terms are 1, 2, 3, 7. So this much of informations are enough to answer most of the questions which are targeted on the full adder, full subtractor, half adder, and half subtractor. So let's see the questions from this, and then we'll go into the next adder. Okay. So here is the questions, and here intentionally I have designed it's a MSQ questions. Okay. So you see here. So consider the block diagram shown below, right? So you can see this is a half adders, this is a full adder. Which of the following options are true? Okay. The option A is saying sum and carry output of full adder are complement to each other. Option B is saying to implement X1, 4 NOT gate are sufficient. Option C is saying to implement X4, 1 NAND gate is sufficient. And option D is saying X1 XOR with X2, XOR with X3, XOR with X4 is equals to 1. Okay, so this is what the question is. Let us try to answer it. And at the end, I have written repeat if half adder full are replaced with half subtractor, full subtractor. That means if I'm replacing this with half subtractors, this with full subtractor, then you have to again repeat this. So that is what we'll see. Let's get started. Yeah. Anyone? What are the options which are correct in this case? And how is your preparation going on now? So you should be in full energy now, right? So this is the best time to write some of the mock test series. And students who have prepared all the syllabus, it is well and good. In case if some of you are very selective, like I'm just good in this 4 or 5 subjects, so no need to worry. Write those test series, and you see like how much you are scoring from the subjects where you are good. So your overall marks, it can be somewhere around even 40, 45 range, or even 35, 40 range. No need to worry. But the concepts which you are good, if the questions are coming from that particular area, you shouldn't be missing that. So that part you should be very, very careful. Okay. Well, so what is the answer? Mayank is saying answer is A and B. Anybody else? So MSQ model question is introduced from last 2 years. Although in these 2 years, not so much of questions has been asked from this model. But yes, I mean, if the questions, there is a huge scope, like, if people can trouble you. Anyway, to answer this, what I need is, so for a half adder, okay, for a half adder, the sum expression, for a half adder, the sum expression is given by AX or B, and the carry is given by AB, right? And this is what you should know first. Okay, by taking this into consideration, I can easily evaluate what is this X1. X1 is nothing but what? X1 is nothing but the sum output of the half adder. It is A, X, or B. So A means this is the input, which is A, X, or B, and B is 1 here. That means what is X1 if I ask you? It is A, X, or B, and X, or 1. So this is equivalent to, I can say, it is A, X, NOR with B. How is that? Because, like if I say what is A, XOR with 1, that is A complements. So if A, XOR B is XOR with 1, then it is A, X, NOR B. So X1 is A, X, NOR B. Now, what about this X2? So X2 is the AND combination of A and B. So A is A, XOR B, and B is 1. So what is X2 if I ask you? So X2 is nothing but your A, XOR B only. So we got X1 and we got X2. Now, what is this X3? We have to see. Now, to get this X3, okay, to get this X3, so this is a full adder we have to deal with. Okay, so what happens in case of a full adder? In case of a full adder, the sum is given by A XOR B XOR C, and the carry is given by AB plus BC plus AC. So in this case, the ABC input, that is X1, X2, and the third input is 0 here, you can see. So what is X3? X3 is X1, XOR X2, XOR with 0. So this is basically, I can say, this is X1, XOR with X2, XOR with 0, but A XOR with 0 is A. So X3 is simply X1, XOR with X2. So what is X1? X1 is nothing but A XOR B. What is X2? X2 is basically A XOR B. So they are complement to each other, isn't it? And if I ask you what is X3, X3 is basically 1, because A XOR B and A XOR B are complement to each other. If I ask you to find the XOR of A XOR B with A XOR B, the answer is definitely 1. So what about the option A? Sum and carry output of full adder are complement to each other. So let us first find carry, and then we can comment this properly. So what is carry? Carry is AB plus BC plus AC. So wherever C is there, so that term will be 0, because the C is basically 0, na? C is basically 0. So this term is 0, this term is 0. So it is basically AB. AB means the AND combination of this and this. So what is this AND combination of this and this? AND combination means I need A XOR B ANDed with A XOR with B. That's what we need, na? So what is this A XOR B ANDed with A XOR B? So this is something like A is ANDed with A bar. So what is A ANDed with A bar? Is basically 0. A ANDed with A bar is basically 0. So what is the answer for the first one? Okay, so this is what we got. So coming to option A, sum and carry output of full adder are complement to each other. So X4 we are getting it is 0 here, and X3 is 1. So sum output is 1 and carry output is 0. So 1 and 0 are complement to each other. So option A is correct. Option B, to implement X1, 4 NOT gate are sufficient. So what is this X1? X1 is A XOR B. And how many NOR gates are needed to implement a 2 input XOR gate? What is the answer? So if you remember, so this is some standard information. So let me just give you here. In the logic gate topic, in the theory, you have learned this. So you see here. So to design XOR gates, we need here 4 NAND gates. And to design XNOR gate, we need 5 NOR gates, you see. Isn't it? So this is A XOR B, this is A XOR B. So you need here 5 NOR gates, and here you need 4 NAND gates. Then to if we attach one NAND gate at the output, it becomes XOR gate. That is for 2 input XOR gate, 5 number of 2 input NAND gate needed. Similarly, for 2 input XNOR, 4 number of 2 input NOR gate needed. See here, for 2 input XNOR, 4 number of 2 input NOR gate needed. So what is the option given here? To implement X1, X1 means what? A XNOR B, 4 NOR gate are sufficient. This is the correct answer, B. See, to implement X4, 1 NAND gate is sufficient. To implement X4, so what is X4? X4 is 0. And to implement this 0, do you need NAND gates? We don't need any NAND gates. So option C is no way correct. And what is option D? X1 XOR with X2. So X1 is basically A XOR B. X1 is basically A XOR B. And what is X2? X2 is basically A XOR B. So X1 XOR with X2, then XOR with X3. What is X3? X3 is basically 1. And then XOR with X4. X4 is basically 0. So this is, let's say, if I'm saying this is X XOR with, this is X bar, XOR with 1 XOR 0 is 1. So what is X XOR 1? So 1 XOR 1 is basically 1. Right? You can see here. So X1 is A XOR B, X2 is A XOR B, X3 is 1, X4 is 0. So if I assume A XOR B is X, then A XOR B is X bar. And overally, XOR with 1 XOR 0 is 1. So X XOR X bar is 1, 1 XOR 1 is 1. So this is also correct. Right? So A, B, and D are correct answers. So in the previous sessions, I haven't taken any MSQ questions, but this is a MSQ questions. So with this, your concepts of half adders and full adders, you have revised it. So anybody, I mean, the second part of questions I'm not solving, I'm giving this you as a homework. If the half adder is replaced by half subtractor and full adder replaced by full subtractor, okay, then which of the following options are correct? Okay, you have to see accordingly. So the only difference in this case will be in case of half adder if it is a half adder. So what happens in case of a half adder, and because for please half subtractor, so I can say in a half subtractor, the difference expression is again it is A XOR B, and the borrow expression is it is A bar B. And in case of full subtractor, what happens? In case of full subtractor, if it is a full subtractor, in case of full subtractor, the difference expression is A XOR B XOR C, and the borrow expression is A bar B plus BC plus A bar C. Okay, so again the same story has to be repeated. Okay, so you please do this little bit Boolean algebra needed. So I hope based on the previous sessions you can easily answer this. Okay, let us see this. This is the second questions I have taken. So we have a full adder, this one, and we have full subtractor. Okay, so their corresponding sum carry are given to the AND gates, and it is given to half subtractors. So we are supposed to get the mean term and max terms of D and B. What is the mean term of this and what is the mean term of this borrow? Okay. So logically, it's not a big deal. Okay. So one thing you should know, if it is a full adder, okay, the sum, if I ask you, just now I have shown you. So in case of the sum, what are the mean terms and max terms we have seen. So let's see. Yeah, here you can see. This is what is the information we need. Okay, see. So for a full adder, the sum is given by 1247, right? And for a full subtractor, it is again 1247, the difference. But for a full adder, carry is 3567, and for a full subtractor, the borrow is 1237. One concept that I'd like to use in this case is the AND gate act like a intersection operator, or gate act like a union operator of the mean terms. So I know the mean terms of the sum and mean terms of the carry, right? So mean term of the sum are 1, 2, 3, 7. 1, 2, 4, 7. And for carry, it is 3, 5, 6, 7. 3, 5, 6, 7. So if these sum and carry are given to the AND gate, so what is the mean terms you are going to get? Mean term is nothing but, in this case, because it's an AND gate, you need the intersection of these mean terms. So what are the intersection? Which mean terms are common? So the only mean term common is mean term number 7. Mean term 7. Similarly, if you see the difference and borrow, so difference having 1, 2, 4, 7, and borrow having 1, 2, 3, 7, isn't it? So here the common mean terms are 2 and 7. 2 and 7. So here it is 7, and here it is 2 and 7. Yes or no? So we got the mean terms of the inputs of the half subtractor, right? So what is the how do you deal with this half subtractor now? So coming to this half subtractor, the difference is given by a bar b plus ab bar, that is a XOR b. So if I ask you this way, okay, so what is a bar? A bar means what? So this is what A input you can think of, this is what your B input you can think of. If A is having mean term 7, then what are the mean terms of A bar? Those are missing things. That means 0, 1, 2, 3, 4, 5, and 6. So these are the mean terms of A bar. If A having mean term 7, then all those missing index between 0 to 7 except 7 will be the mean terms of A bar. And with B. So what is B? B mean terms are 2 and 7. Then or with AB bar. A is 7, B bar. So except this 2, 7, that is 0, 1, 2 is there, 3, 4, 5, and 6. Okay. So this is A bar, this is B, this is A, and this is B bar. So if I ask you, what do you get from the first two things? So it is only 2, I guess, because the common factors are only 2, 7 is not common. And from this, what do you get? You don't get anything. So it's a null set. You don't get anything. There is nothing common. This is 7 and 7 is not here. So if I ask you, what is the overall this thing? So it is mean term 2 only. It is mean term 2 only. So the mean term of difference is nothing but 2. Okay. And what about the borrow? So borrow expression is given by A bar B. So A bar B itself is this term. This is what A bar and this is what B is. So A bar B, if you see, so the common fact is again 2. So this mean term is 2 and this mean term is 2. Okay. So if these are the mean term, if I ask you what are the max terms, so max term for the difference, if I ask you, so the max terms will be 0, 1, 3, 4, 5, 6, 7, except 2, remaining all index, they will be coming in max term. Same is the story for the borrow as well. Are you following or not? Are you getting the same answer or anything else? Yes, guys, please respond. So what concept I have used? So here the fact that you should, why I have taken this particular question is, if you see the previous year GATE questions, directly or indirectly, they are targeting the question based on this mean term, max terms of this half adder, half subtractor, full adder, full subtractor. So here I have just taken the full adder and full subtractor, and we have used the union intersection concepts. So by following that, we are getting this. So we have only one mean term for the difference, that is mean term 2, and one mean term for the things, that is mean term 2 again. Mayank Roy and Sumit Sir Ghosh, you are getting the same answer. That's great. And this is what is one of the frequently asked model questions. I'm putting a 3-star. Okay. So this question is based on the ripple carry adder. The question here is, if all the inputs are applied at t equals to 10 nanosecond, then what time the final output will be available? So here, like basically we have 4 adders. This is a half adder, full adder, full adder, full adder. And their sum and carry delay are also specified. Like for this adder, the sum delay is 5 nanosecond, you can see. Carry delay is 2 nanosecond. Similarly, for the second adder, the sum is 10, carry is 3 nanosecond. Third adder, this is 8 and 4, this is 1 and 5. So the delay of all these devices are different. Then we are supposed to find if all the inputs are applied at t equals to 10 nanosecond. Okay, see this, at t equals 10 nanosecond, So then at what time the final output will be available? Okay. So this is the ripple carry adder. And for ripple carry adder, we have this standard formula. If we assume some delay are uniform for all adders and carry delay also uniform for all, then the worst case delay is n minus 1 into TPD of sum plus maximum of TPD sum, comma TPD carry. This is the formula you may use provided the delay is uniform. Okay, if all the adders are having same delay, you may use this formula. Otherwise, it's not. So otherwise, if you get the questions where the delay are different, then the only thing is whatever the concept you have learned in your theory that you have to use to solve this. Okay, so how do you answer this? One thing that should all of you should get idea is, so unless until the carry output of this adder is not produced, then this adder is not receiving its all three inputs. So this adder having three inputs, two inputs are direct inputs, and this is coming from the previous stage. So unless until this is not available, okay, then this adder cannot produce its output. Similarly, unless until this is not available, this cannot produce this out, because this is what is the output is nothing but acting as input to the next stage. Okay, same is the story. So how do you answer this? So if I assume at t equals to 10 nanosecond, the inputs are applied. Which inputs? These inputs, these inputs, this input, these inputs. So they are given at 10. So if they are given at 10, I'll be getting this carry output of the first adder at 10 plus 2 at 12 nanoseconds. I'll be getting at 12 nanoseconds. So at 10 nanosecond inputs are applied and its delay is 2. So 10 plus 2 is 12 nanoseconds. So I'll be getting this at 12 nanoseconds. Like the reference is 10 for this, the reference is 12 for this. If you are getting this at 12 nanoseconds and its carry delay is 3 nanoseconds, so you'll get this at 12 plus 3 at 15 nanoseconds. So that is at 15 nanosecond, your all three inputs are available. So at 15, you are getting this, and its own delay is 4. So 15 plus 4, this is 19 nanoseconds. If this is 19 and 5, this is becoming 24 nanoseconds. Okay. And if you want to ask me, sir, what is the sum delay? So sum delay is 20 nanoseconds. That means if all the inputs are applied at t equals 10 nanosecond, at 24 nanosecond, we'll be getting the carry outputs, and at 20 nanosecond, we'll be getting the sum outputs. So if somebody asks you what is the worst case, it is 24, because if I go with 24, all the bits output I have already obtained. Okay, this is what the approach is. So even if you don't know that formula, if you know this concept, you can easily answer this. But if it is all these relay would have been same, okay. I mean this let's say if I'm saying all these delay, all these 8 delays which I've mentioned, if I'm saying that let's assume the sum and carry delay of each adder is 2 nanosecond, then what are the answers? So the worst case delay in this case will be n into TPD. So that is 2 into 4. N is nothing but the number of adder, that is 4. 2 is nothing but delay of this. 2 into 4 is 8 nanosecond is the delay. But if the inputs are applied at 10 nanosecond, so 10 plus 8, that is 18 nanosecond, we're getting the outputs. If the delay are uniform, if the input applied at 10, then the answer would have been 18. Otherwise, this way you have to go. Okay. So, yes, here is a question from magnitude comparators. So the question is, in a 5-bit magnitude comparator, for how many combinations A greater than B, A less than B, A equals to B? Who can answer me? This one. In GATE 2012, there is a questions based on this model, and it's a formula-based questions. So for 1 mark or for the numeric answer type, you may expect such kind of question in the upcoming GATE 22 exam. In a 5-bit magnitude comparator, for how many combinations A is greater than B, A is less than B, and A equals to B? What is the meaning of 5-bit magnitude comparators? So if I am saying it's a magnitude comparator, A is a number and B is a number. So this A is of 5 bits and B is of 5 bits. Okay, that is what is the meaning of 5-bit magnitude comparator. That is, the individual numbers are 5 bits. So in this case, we have again some well-known formula. Okay, so this is the corresponding formula. So let us take that. and try to answer it. In an n-bit magnitude comparator, okay, A equals to B is for 2 raised to power n number of combinations. And for A greater than B and A less than B, the number of combinations are equal. That is 2 to the power 2n minus 2 power n divided by 2. So the same is the formula for A less than B as well. So with respect to this particular questions, in this particular formula, you simply substitute n equals to 5. So A equals to B means 2 raised to power 5, that is 32. And for A greater than B, it is 2 raised to power 2 into 5, 2 raised to power 10 minus 2 power 5 divided by 2, and same is the answer for A less than B. For both of these cases, this is what is the answer. That is 2 to the power 10 minus 2 to the power 5 divided by 2. This will be your answer. Please evaluate. That is the answer. 2 to the power 10 is 1024 minus 32 to raised to power 5 divided by 2. That is 992 by 2. That will be how much? 450 and 450, 496. Is that? I think 496. So total number of combinations are 2 raised to power 2n. Okay. Out of 2 raised to power 2n, 2 to the power n, which is 32. This is for A equals to B. And remaining combination, that is 2 to the power 2n minus 2 to power n. Okay, so that will be equally half for A greater than B and A less than B. That means out of this, so you have 496 combination for what A greater than B, and 496 combination for what A is less than B. Okay, na? This is what is the answer. Yeah. So this question I have taken from the decoder. Okay. So there are two diagrams here you can see. So one diagram is for an active high decoder, and the other one is for an active low decoder. So the question is obtain min term of y. Okay, obtain min term of y. So what is the concept that you need in this case? What is the concept that you need in this case? So it's an active high decoder. It's an active low decoder. How do you know this? These bubbles, these symbols are, like from this itself, you can easily guess it is an active low decoder. And if there is no bubbles, it is an active high decoders. So what is the concept you need in this case? Remember, in an active high decoder, each output represents mean term. In the active low decoder, each output represents max term. Okay. So in this case, each output of the decoder is mean term. And in this case, each output of the decoder is max term. That's the concept you need. So if I ask you, so I'm supposed to find what is the mean terms of y. So here, if you see, y is from this XOR gates, and XOR gate inputs are from this NOR gates and this AND gates. So this particular NOR gate having mean term 2 and mean term 4. So this is having the mean terms are 2 and 4. And what is it? This is mean term 5 with mean term 7. I think you know this mean term I added with mean term j is equals to, if you are doing AND of any two random mean terms of different index, its product is always 0. So this is mean term 5 and this is mean term 7. So their product is basically 0. Okay. So this is what now you have to get for this XOR gate. What is the output of the XOR gate? So output of the XOR gate is A plus A bar B bar. So A is this things. Okay. A is this thing. So this is what your B is. This is what your B is. So tell me, what are the mean terms of this y in this case you'll get? Any answer? So if you understood this, the next question also you can easily answer. It is AB plus A bar B bar. So A having mean term 2, 4. And what is this B? So B, I am saying that it is output is 0. But what is the mean term? Whether the mean term is 0? Mean term, if you say, okay, this is equivalent to mean term 0, is that correct? Or it's wrong? So what is the meaning of this 0? The meaning of this 0 is output is always 0. If output is always 0, that means there are no mean term. It is having only max term. So if you say it is mean term 0, this is a nonsense you are doing. Okay, so you are not supposed to say this. So I can say in this case, so if you want to ask me, max term 0, 1, 2, 3, 4, 5, 6, and 7. This is correct. But it is not having any mean term. So between A and B, is there anything common? Nothing is common. So you get nothing from this. That is null set. And from A bar and B bar. So what do you get from A bar and B bar? So you don't get anything from this. This is null. Don't say that mean term 0. Mean term 0, if you say the meaning is different, it means if you are applying the input 0, 0, 0, the output is 1, which is not correct. That is what you are not want to tell here, right? And for this A bar, B bar, from A bar, what do you get? The complement of this, that is 0, 1, 3, 5, 6, 7. This is what you will get from A bar. And what do you get from B bar? So B is these things. So B bar, I mean, all this will come into pictures, right? I mean, which are max term of this, so they become mean terms of B bar. That is 0, 1, 2, 3, 4, 5, 6, and 7. So the common factor, if you see, 0, 1, 3, 5, 6, and 7. 0, 1, 3, 5, 6, 7. This is what is the right answer. So Soumya, Kusagra, Mayank, you all are giving the right answers. And yes, this is correct. So here is a very silly mistake. Like people, if they get 0, they will say it is mean term 0. Don't say that it is mean term 0, okay? And the similar intersection concept, again, we have used. Now, any idea what is the answer of the next questions? So what are the mean terms of this y? What is the expression, I mean, the mean terms or max terms of this y? So what concept you need in this case? Remember, max term I plus max term j is equals to always 1. Okay, it is always 1. So this is your max term number 3. So this is max term number 1. This is max term number 2. So if I am asking you what is max term 1 or with max term 2, this answer is always 1. This answer is always 1. And what about this? So this is your max term 3 and this is your max term 5. Is that no? So this is nothing but max term 3 added with max term 5. So what is this y basically? Y is nothing but XOR combination of 1 and this. So y is equals to 1 XOR with max term 3 added with max term 5. So it is equivalent to max term 3 added with max term 5 complements, because you know 1 XOR with A is equals to A bar. So 1 XOR with this thing is complement of these things. So this is equivalent to max term 3 complement plus max term 5 complements using De Morgan's law. So you know this mean term I complement, max term I complement is equals to mean term I. Max term j complement is equals to mean term j. So if it is max term 3 complement, you get it is mean term 3. Max term 5 complement is you get it is mean term 5. So what is the mean terms of the y means? The mean terms are 3 and 5. The mean terms are 3 and 5. Are you getting the same answer? Mayank, you are saying the answer is 0. Soumya, you are saying the answer is 1 and 2. How is that? In fact, same is the story we could have applied in this case as well. You see here. So in the first problem, so the mean term 2 and 4, and this is 0 we got. So in this one of the alternate way without going this much of this thing is what somebody can do in this case to save some time, that y is equals to, it is 0 XOR with mean term 2, 4. So it is basically complement of mean term 2 plus mean term 4. Yes or no? So this is mean term 2 complement added with mean term 4 complement, which is max term 2 into max term 4. If it is max term 2 into max term 4, it is equivalent to mean term 0, 1, 3, 6, and 7. 0, 1, 3, 5, 6, 7. This is what the answer we got, right? So here also same story. So here OR gate output is 1, and this is max term 3 with max term 5. So if it is XOR gate, it work like inverter if one of the input is 1. So it is complement of max term 3 and with max term 5, which is max term 3 complement or with max term 5 complements. Max term 3 complement is mean term 3, max term 5 complement is mean term 5. Okay, so the mean terms are 3 and 5, and all those missing index, so they become max terms. All of you are getting same answer or anything else? Soumya, Kusagra, Mayank, whoever else. Why other people are not participating? Please respond. Let it be wrong. Okay, no need to hesitate. Okay, yes, now fine. So suppose sometime like the question can be asked, if a full subtracted borrow expression to be designed using a let's say active low decoder, then what is the process? So they may set some options. Okay, so let us try to answer such question, one of such questions. Okay, listen. If it is a full subtractor, we know the difference expression is the mean term. If I ask you, is mean term 1, 2, 4, 7, or if you want to know this in terms of max term, it is 0, 3, 5, and 6. Similarly, borrow, if I ask you, okay, borrow in this case, the mean terms are 1, 2, 3, 7. And what are the max term if I ask you? So those are nothing but 0, 4, 5, and 6. Isn't it? So, because in case of active low decoder, so each output are max terms. So we prefer the AND gates. So one AND gates, I will be making this to get the difference outputs. One more AND gate I'll be making to get the corresponding borrow outputs. So I expect here 0, 3, 5, 6. And I expect here 0, 4, 5, 6. So I'll be connecting 0, 3, 5, 6, because I know these all are nothing but the max terms. Similarly, in this case, I'll be connecting 0, 4, 5, and 6. That's all. Very simple. And if it is active high decoder, it is wise to use the OR gate instead of AND gates. Okay. Hopefully it is fine. Yeah. Let us switch into the multiplexer segment now. So in this case, again, you are getting some question in the GATE exam. Some multiplexer will be given. So they will be asked to find the output expression sometime, or the mean terms or max terms of the corresponding multiplexers. Sometimes they're connecting to multiplexer in cascade and they're asking. So this is one of such questions I have taken here intentionally. Let us see what is the answer. Anyone? I'm just giving you 1 minute of time. Let me know. And students who are watching it live, please give a thumbs up. And if you haven't subscribed, subscribe to our channel once. Okay. So such kind of video will be continuing, okay, till the GATE exams. So it motivates somehow. Okay. Please give a thumbs up if you haven't yet. Okay. So yeah, tell me, what is the max terms? So how much time will it take? It shouldn't be taking much more than 30-40 seconds. Maximum 40 seconds. And such kind of questions are suitable only for the 1 mark only. So A XOR 0 is A, which is I0. Okay, 0, 1, 2, 3. B OR with 1 is 1. C OR with 0 is 0. D XOR with 0 is D bar. Yes or no? So why, if I ask you, okay, it is S1 bar, S0 bar, I0. So if I write directly, C bar D bar A plus C bar D1 plus C D bar 0 plus C D and this D bar. So this term is 0. This term is also 0. So I'm left, I can write this as A C bar D bar plus this is C bar and D. So in this case, the expression in soft form, so we can get the mean term, and if you get mean term, we can find the corresponding max term, which is the question here, right? So if you see, I have A, B is missing, C bar and D bar. I have A, B missing, then I have C bar and D. Okay. So 0, 1 is the combination 1, 1, 0, 0, 0, 0, 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. So for this Y, if I ask you what are the mean terms, the mean terms are 8, 12, 1, 5, 9, 13. That is the mean terms. If I rearrange it, 1, 5, 8, 9, 12, and 13. These are the mean terms. But the question is to find the max terms. If these are the mean terms, so the remaining missing index between 0 to 15, so that will be max terms. 0, 1 is present, 2, 3, 4, 5 is present, 6, 7, 8, 9 present, then 10, 11, 12, 13 present, then 14 and 15. So 0, 2, 3, 4, 6, 7, 10, 11, 14, 15. So these are the corresponding max terms. Or they may ask how many max terms are there. If the number of mean terms are 6, number of max terms should be naturally 10 because some of them should be 16. So these are the corresponding max terms. Hopefully, all of you are getting the same answer. Is that? Okay. This question is asked in one of the civil service examination paper previous year. Okay, in GATE exam also, such kind of question has not been asked from last couple of years. So it is expected, like in the upcoming exam. So you may get one question from this. Okay, so the question is, how many 4-input multiplexes are needed to implement a 256 input multiplexes? How many levels will be there? Okay, so this question is something similar to this. Suppose if I'm asking you to design a 8x1 multiplexes using 2x1 multiplexes, then how do you solve this? So the required number of input is 8, given number of input is 2. So we do 8 by 2, 8 by 2 is 4. So we do 4 by 2, 4 by 2 is 2, 2 by 2 is 1. So you follow this approach. That is, so 4 plus 2 plus 1. The number of levels will be total 3 levels. Level 1, we need 4 multiplexes. Level 2, you need 2 multiplexes. Level 3, you need 1 multiplexes. So total number of multiplexes needed is 7 and number of levels are 3. This is what the same approach you have to do. So here, the number of input required is 256 and the given structure available is 4. So it is 256 by 4. Now, what is this 256 by 4? I think this is 64. 64 by 4. So where this 4 is coming, this 4 is coming, the given structure is 4. So continuously, I have to divide it by 4 unless until I get 1. So 64 by 4 is 16. So 16 by 4. So what is 16 by 4? 4 by 4. I'm stopping here. If I'm going one more step, then this will be 1 by 4. And you cannot have a fraction number of multiplexes, isn't it? So wherever you get 1, you stop. So 256 by 4 is 64 plus 16 plus 4 plus 1. If you sum all of this, so this is coming 85. So number of multiplexer needed is 85 and number of levels are 1, 2, 3, and 4. The answer is option A. You need 85 number of multiplexes, and there will be 4 levels. In level 1, you have 64 multiplexers. In level 2, 16 multiplexer. Level 3, 4 multiplexers. Level 4, 1 multiplexer. Okay, na? So this is what the answer is. So let us answer the next questions. Design a system using 4x1 multiplexers with the maximum combination 1, 4, 6, 7, where BC is select line. Okay, so such kind of questions also are because see in the combination circuits, if you ask me which is having highest chance to come, definitely it is from multiplexers and that adder subtractor. Okay, these are two areas where 90% of the chances questions will be asked from the combination circuits. So in multiplexers, you have different varieties. One of the varieties to find the output expressions or the number of mean terms. That is one category. Second category is such kind of system design. Okay. And the third category is some mean terms maximum combination will be given, and they will be asking you what should be connected to this input, that input, so that this system will be designed. So let us answer this one. So for this, that means what I'm supposed to do in this case is, so basically the question is something like this. So this is your B and this is your C. So here is your 0, 1, 2, 3. So I am supposed to find what should be connected to this 0, 1, 2, 3 terminal such that the output max terms are 1, 4, 6, 7. So if the max terms are 1, 4, 6, 7, the mean terms are 0, 2, 3, 5. Is that 0, 2, 3, 5? So the mean terms are 0, 2, 3, 5, or the max terms are 1, 4, 6, 7. So for that, we have to make a table. So because BC is your select line, the remaining variable is A. So A having two combination, A bar and A. Here I'm writing here I0, I1, I2, and I3. So what is the numbers I'll be getting from A bar? 0, 1, 2, 3. And here I'll be getting it is 4, 5, 6, and 7. So from where these numbers 0, 1, 2, 3 are coming, because if you're writing the ABC combinations from 0, 0, 0, 0, 0, 1 like this up to 1, 1, 1. So the corresponding the numbers where A is 0 is 0, 1, 2, 3. I mean, in the first 4 combination, you get A is 0. So in place of A bar, I'm writing those numbers 0, 1, 2, 3. And in the bottom 4 rows, that is 4, 5, 6, 7, you get 1. So I'm writing here 4, 5, 6, 7. Okay, so this is the table. Then what I have to do, I have to see what are the mean terms I need. I need mean term 0, I need mean term 2, I need mean term 3, and I need mean term 5. So see, this is what I need. So if the max terms are given, first you obtain the mean terms. Then here, this is what highlighted, the corresponding row value is A bar. Here, this is highlighted, the corresponding row value is A. Here it is again A bar, and here it is again A bar. Suppose the question would have been 0, 4, okay, 0, 4, 2, 7. Then what could have happened? If it is 0, 4, 2, 7, so what could have happened? This is 0, 1, 2, 3. This is 4, 5, 6, 7. 0, 4, 2, and 7. So here both are circled. It is 1. None of this is circled. It is 0. This is circled. The corresponding value is A bar. And here 7 is circled. The corresponding value is A. So if any 1 is circled, the corresponding value is the row value you have to take. If both of them are circled, you have to take it 1. If none of that is circled, you have to take it 0. So as far as this question is concerned, this is A bar. This is your A, this is your A bar, and this is your A bar. If this could have been given 0, 4, 2, 7, then you would have connected here 1, then 0, then A bar, and then it is A. Okay, this is what is the answer. Sometime, instead of having the BC as the select line, they may say use AB as select line or use AC as select line. So accordingly, from this table, you have to see what is the corresponding numbers you have to write here. So let us do that. So suppose if I'm saying that I don't need BC as select line, I need AB as select line. So what will happen then? So what should be connected? If AB is in select line, then what should be connected to the input segment? If AB is used as select line, then what's going to happen? Then you have C bar and C. So C bar combination, if you see, it is 0, 2, 4, 6. C is 1, 3, 5, 7. So the corresponding these things you have to encircle. So you get 1, 4, 6, 7 means, I mean, it is again your 0, 3, 0, 2, 3, right? 0, 2, 3, 5. 0, 2, 3, 5. So 0, 2, 3, and this is 5. So you get here C bar, you get here 1, you get here C, and you get here 0. So the corresponding combinations are C bar 1, C, and 0. C bar 1, C, and 0. So in such kind of question, read the question carefully. What is the select line? You cannot have a universal answer for this. So what is the corresponding this thing? So you have to see that, which is the select line. So accordingly, the answer will change. So they will jumble the options. And again, carefully. So in the original questions, they may give max term sometime or mean term. But whatever the technique I have explained, that is with respect to mean term. If it is mean term given, well and good. Otherwise, if it is max term given, first you try to get the corresponding mean terms and then you can proceed. Sometimes some logical questions can be framed something like this. So there are two questions. The first question I have taken is from ESC 2017 of electronics. Even the second question is from the ESC 2017 electronics. So the first question is, a circuit outputs a digit in the form of 4 bits. 0 is represented with 0000, 1 is represented with 0001. Okay, by 9 by 1001. A combination circuit is to be designed which takes these 4 bits as inputs and output as 1 if digit is greater than or equals to 5 and 0 otherwise. If only AND or NOT gates are used, what is the minimum number of gates required? Okay, what is the minimum number of gates required? So what is being said? So here, so let's say the number is having 4 bits. I'm denoting this by ABCD. The corresponding output is Y. So a circuit outputs a digit in the form of 4 bits. 0 is represented by 0000. Okay, like this. A common circuit design which takes these 4 bits as input. So if there are 4 bits, how many combinations possible? 8 combinations are possible. 2 power 4, 16 combinations are possible. It's a good question. Okay. So here it is saying a combinatorial circuit is designed which takes the 4-bit input. Output is 1 if digit is greater than or equals to 5 and 0 otherwise. That means if the number is more than 5, I mean more than or equals to 5, then the output is 1. So that means there are 16 combinations. So if I'm putting a line here, so above this line, outputs will be zeros because the condition is if the digit is greater than or equals to 5, then only the corresponding output is 1. So for the bottom rows, these all outputs are 1. Right? So if I ask you what is the mean terms of Y, so the mean terms of Y, you can say it is 6, 7, 8, 9, like this, up to 15. So they're asking, so this is what is the output is. So how many gates are needed if the these things is AND or NOT gate are necessary, right? So for that, so first I would like to get it simplified expressions and then we'll decide. So I'm going with a 4-variable map because it's a 4-variable cases. 6, 7, 8, 9, 0, 1, 3, 2, 4, 5, 7, 6. Then these are all 1. Okay. So if you see, you have a octet here and you also have a quad here. Very simple, straightforward. So this is A bar, B bar. This is A bar, B. This is AB. This is AB bar. This is C bar, D bar. C bar, D. This is CD and this is CD bar. So from this octet, you get it is only A. And from this quad, you get this is from row, you get B. And you get B and you get C. And I think I'm missing also 5 also I'm missing, no? 5 is also there. Sorry, it is 5 is also there. So this is also one of these things. So if this is there, then to cover up this mean term, again, you have one possibility of quad here. This is the third quad possible. And what is the expression of the third quad if I ask you? Then the answer is from row you get it is B, and from column you get it is D. So that means if I'm asking you, what is the corresponding this answer? Okay, that is the expression of Y. So Y expression is A plus BD plus BC. If it is A plus BD plus BC, A, then you may take B as common. If you take B as common, it is D plus C. So if I ask you to implement this, so you need a OR gate. The inputs are D and C, so that the OR gate is producing your D plus C, and then you have B. So this is your B line. Okay. So then this and A line should be connected to OR gate to get the outputs. So this expression B and with D plus C you'll be getting here. So this should be OR with A. So this is what your A is. So number of gates that we have used is 1, 2, and 3. So after getting the K-map expressions, so you may think, okay, for this one AND gate, for this one AND gate, 2, then we need 2 more OR gates. So answer is 4, you may say. But you see here, you can take this B common and some kind of optimization you're able to do. If you do that, the answer is definitely it is 3. Okay, na? And what about the these questions? So like in the multiplexer case, we have 1 questions. So like similarly, we have 1 questions from decoder. So the question is, how many 3 to 8 line decoder with an enabler input needed to construct a 6x64 decoder without using any logic gates? Okay, so yes, tell me. Tell me. So, like in the multiplexer case, we used to see the number of inputs of the given structures and number of input of the required structures. Similarly, here you need number of output of the required structure, which is 64, and number of output of the given structure, which is 8. Number of output of the required structure is 64, number of output of given structure is 8. So you do again the same division, 64 by 8, that is 8, and 8 by 8, that is 1. You stop here. So this is 8 and this is 1. So total number of decoders necessary are 9. So how many levels are necessary? The level necessary are 2 levels. So this level need 8, this level need 1. 8 plus 1, 9. So the answer is 9 for this. Okay. So these many questions I have taken to cover this combination of circuits. So we have solved questions based on half adder, half subtractor, full adder, full subtractor, ripple carry adders. Around 3-4 questions we have solved. 1 question we have solved based on this magnitude comparators. And based on multiplexer, 1 question we have seen to design that one, right? So this is one model we have seen. Multiplexer tree, I mean, to design this 256, how many multiplexer needed? Cascade structures also is one possibility, like 2 multiplexers or more than 2 multiplexers will be cascaded, and they will be asking you to find the output expressions or the mean term or max terms of outputs. So that one question can be expected. And what is multiplexer tree? Multiplexer tree means this is what multiplexer tree. So I mean this diagram, when we design a bigger structures multiplexes using smaller structures, the overall circuit is called multiplexer tree. And based on the decoders. So based on active high decoder, based on active low decoder, we have solved it. So I can tell you, right? So you go through the previous year question papers. I hope all of you are listening. You have already practiced all those question papers. If you see all the questions of combination circuits, 90% of the questions will definitely come under these 10 questions which we have solved today. And in GATE 2022 exam also, whichever the question will come, most likely it is from any one of these collections. Of course, in a single set, we cannot expect question from every concept. But if there is one question from combination circuits, most likely it is from these all things which we have discussed. So I hope this session is definitely helpful for you. So for today, here I am stopping. Thank you. So so what is your responsibility then now? So responsibility is such kind of quick revision you should make, and you should write the test to build up your confidence. And before 3-4 days of exams, there is no need to write test series and unnecessary boosting up in a moral way or in a demoral way. So that is not necessary. So I will not suggest to write test before 3-4 days of exams. So whatever you are doing before January 26, you finish it off. After January 26, let it be 1 week, 10 days, 4 days, whatever the time you get. You simply relax, and sometime if you feel you have to revise, you think. So people, they used to get thought like, okay, these many things are left, that many things are left, I have only this much of small time. Okay. But you feel like that, but once you see the question papers, your hand and mind will start working automatically. Okay. No need to worry for that. But unnecessarily, no need to lose confidence at the end moment of the exams. That's very important. Thank you. This is all for today. And in next sessions, we'll